Hello, welcome back to another tutorial. So if you are joining us for the first time, my name is Okunamba George. I teach Python, machine learning, and every other thing that has to do with data analysis and data science. So in this tutorial, we're going to look at how to build our first neural network using TensorFlow with TensorFlow dataset Cypher 10. So without any further delay, let's dive into our Jupyter notebook. Alright, so I've already opened my Jupyter notebook. I'm coming to change it. I'm going to say Cypher 10. Cypher 10 going to be our name. Alright, so the first thing we are going to do is we are going to import some dependencies. So the first thing we are going to do is to import TensorFlow as TF. Okay, so the next thing we're going to say from TensorFlow .keras import, we're going to import data set. We're going to import layers. We're going to import models. Okay, we're going also to import matplotlib for data visualization to visualize our data. Matplotlib.pyplot as plt. Okay, so we will go ahead and run this. Okay, so the next thing we need to do now, we are going to load our data set which we have imported from TensorFlow. If you are joining us for the first time, TensorFlow is a deep learning algorithm or a library for building neural networks. Okay, just like machine learning, we use scikit-learn. So you can also use TensorFlow to do image classification, image or object identification. We can also use to do text analysis. So let's go ahead and load our data set which we have imported from TensorFlow. So we are going to do this function. I'm going to call it as xtrain. Mind you can call it whatever name you want to, but I choose xtrain. It's easier for me to understand. X and y train. Alright, so you're coming out and say comma. You say x underscore test and y underscore test. We're going to load our data set equals to data set. Alright, dots. Okay, data set dot Cypher 10 dot load underscore data. Okay, let's go ahead and run it. Okay, we are having, okay, let's say data set, not data set. Let's run it again. Let's go ahead and run it again. Data, okay, sorry, I misspelled this. Please always check your spellings. Data set. Alright, so what's wrong with me? Data sets, let's run it. Okay, it's capital C, not small c. Cypher. Oof. What is going on here? Cypher 10. Alright, so I was spelling it wrongly. Let's go ahead and run it. Okay, let's wait for it. It's loading. So basically we use xtrain, ytrain, xtest, ytest equals to dataset dot Cypher 10 dot load data. This is a function for us to load our Cypher data set. Okay, we have successfully loaded our Cypher data set. So the next thing we need to do, we are going to normalize our data set. Okay, to normalize means we are going to convert our pixel. Every image pixel is from 0 to 255, so we're going to round it up to 0 and 1. Okay, So let's go ahead and normalize our data. I say X train. I'm just going to copy this. Okay. All right, equals to same, and we say 255.0. We're also going to look at our X test. Okay, we're going to copy our X test as well. Equals to X test 255.0. We have been able to normalize. Okay, it's running. We have been able to normalize our data set. All right, so the next thing we need to do now is to print the shape of our data set. Don't always forget to print the shape of a data set. I can say print X underscore train. All right, train dot shape. All right, you can also do print X test. Okay, the test shape. All right, so we're going to run this. You see that we are looking at the X train is 50,000 and it's 32 by 32 by 3 pixels. It's 32 by 32 pixels and it has three channels. Okay, it's an image, so it's 32 by 32 and it has 3 channels. And the X test is about 10,000 and it's 32 by 32 and it has 3 channels. Okay, so based on this, our data shape we are going to use to do what, to build our neural network using TensorFlow. So the next thing we need to do now is to display our data set. Okay, we're going to display these images that we have just been able to do what, to copy. So that was why we had to import our matplotlib up here. So we're going to say plt. Okay, first of all I'm going to say figure equals to plt.figure equals to the figure fixed size equals to, we're going to say 10 by 10. Now we're going to say for I in range of, we're going to look at least 20 of this. All right, we're going to say a minute please, just give me a minute. All right, so we're going to say plt.subplot we're going to look at 5 by 5 and whatever our I is plus 1. Okay, we're going to also say plt.xticks. Xticks is going to be an empty array. We're going to also say plt.yticks. All right, also we're going to make it an empty array. Now we're going to say plt.grid. I'm going to set it to false, and we're going to say plt.imshow to show the image. All right, so we're going to show our X underscore train and whatever our I is. Okay, all right, so we are going to also say plt.show. all right, so let's go ahead and run. Okay, we're having an error. Subplot takes from 0 to 2 for an argument, but 3 were given. Okay. Subplot 5, 5, I plus 1. Okay, let me just go ahead and run this again. All right, so we are going to go ahead to run this because we want to view our plots. What I need to do now, the first what we did say plt.figure fixed size we say 5 over 5, 5,5 for I in range of 10. We want to display 10 images. BLT.stop-plot, okay, we say 5 is going to be 5 by 5 plus the I and plus 1, X sticks and empty array, and grid false. Then we are going to show, and we are going to say CMap equals to gray, and we are going to head and run this. Alright, so we have been able to 1, 2, 3, 4, 5, 6, 7, 10, okay. So alright, fine, we can also increase this to 20. Alright, you can say, okay, we want to see 20 of this, and we run it. We are going to see 20 of this. So we have been able to successfully visualize our image. Alright, so the next thing we need to do now is we need to go ahead and build the CNN model, convolutional neural network. It's basically used to do or to build image classification. Alright, so we are going to say model equals to models dot, we are going to use sequential, okay, sequential, and it's going to be a list. The first thing we say layers dot conv2d, and it's going to take 32, alright, comma 3, 3, 3, 3, 3, 3. Alright, so the next thing we need to do, we need to look at the activation. We say activation equals to, we're going to use ReLU, okay, and we're going to use input underscore shape let's see. Alright, so input underscore shape, we're going to use 32 by 32 and the 3. Alright, so we are going to say comma, and we're going to say layers dot max pooling 2D, okay, it's going to be 2 by 2, 2, 2, alright, comma, we're going to say, I'm just going to copy this, okay, I'm just going to copy this, and I'm going to paste it here. Alright, so but I'm not going to use the input shape. I'm going to remove input shape. I'm going to remove input shape. What's going on? Okay. ReLU. Alright, so I'm still going to copy the max pooling, and I'm still going to copy this. I'm going to change here from 32 to 64 alright, and here I'm going to change it to 64 as well. So what I'm going to do next is layers dot dense, sorry, flatten, okay, it's going to be an array, okay, layers dot dense, alright, I'm going to use 64, I'm going to use activation, it's going to be equals to, we can use softmax, we can use ReLU. Alright, so we are comma, I'm going to say layers, so I'm going to explain everything, dot dense, I'm going to use 10, and activation is going to be equals to what, soft max. Right, so what we are doing here is this, we are building a sequential model. Alright, so I am using convolutional layers. Alright, we say that layers.conv2d is a two array. And if you look at here, we had our shape as 32 by 32 and 3 channel. That's why we are using the first conventional layer 2D is at 32 and 3 by 3 channel. Activation, we are using ReLU. Input shape, we are pasting in our shape, extreme shape 32, 32 and 3 that we are having here. Now the second layer we have is max pooling. It's going to be 2 by 2, and we're going to say okay, we need another conventional 2D, conventional 2D 64. Now when you multiply 32 by 2 is going to give us 64, and we're having this 3 by 3 activation ReLU, no longer input shape. We use input shape once. Now we go ahead and look at our max pooling as well, and we go ahead and look at also our conv2d. We are still repeating 64. We can as well use 128. When you multiply 64 times 2 equals 168. Now this what this does, this layers does, this dense means is connecting, is a fully connected layer. The dense means it connected all. Then the last layer, the dense layer, is at 10 because we have, if you look at our list names here or class names, is there 10 class names. Okay, whatever we are doing here, they are under 10. That's why we are using the last layer, dense layer, as 10, and we are going to use the activation softmax. So we're going to go ahead and run this. Okay, we are having these layers 3 by 3. Alright, so we are going to go ahead and run it again to see. Alright, so we have been able to successfully forget this. It's not an error. If I run it, this error is going to go out. Alright, so if I go ahead and run it the second time, we are not going to have that error anymore. Alright, so it's not an error, it's just a warning. Alright, so the next thing we need to do now, we need to compile our model. Alright, so to compile, we say model.compile. Okay, we are saying optimizer equals to, we are using Adam, alright, comma, and we are using the loss equals to, we are saying space underscore categorical cross entropy. Now we're going to use our matrix. It's going to be a list of what? Of accuracy. Okay, it's going to be a list of what? Of accuracy. Alright, so we are going to go ahead and run this. Trainer compile, what did I use? Model.compile. Okay, optimize. Okay, maybe I have a wrong spelling. Optimizer. Okay, optimizer. Okay, let's go ahead and run this. Alright, so now the next thing we need to do that we need to now to train our model. We have been able to first of all import our dependencies. We load our data set, we normalize our data set, we printed the shape of this, and we went ahead and visualize our data set, which is this dog, horse, and the rest, frog. We went ahead and built our sequential model. We compile this. So what we want to do now, we need to do what? We need to fit in our model. You can give it, let's say, a name. Can say final model equals to model dot fit. We are going to fit in our x underscore train and y underscore train. Alright, so we are going to say epochs is going to be, epochs means the number of times we want our model to see these images. Alright, so, and we don't have a particular number of times you can run this, but you can just run it and see whichever works for you. But note, you don't need to do what to overfit or underfit your model. Alright, so we say epochs equals to what to run it for 10 times, and we're going to use we say validation underscore data. We're going to say equals to x test and y underscore test. We are going to go ahead and run this. X train rather is X train, not train. All right, not train. Okay, it's running. All right, so the epochs have started running. Like I said, epochs means the number of times we want to display these images to the model so the model can look at it, and well, we are saying, okay, model, look at these images for 10 times, so that whenever we fit in a new image that look like this, you can know what to predict for us. So that's why we say epochs 10 times. So we want our model to see these images over and over and over and over again, so that it get acquainted to these images, so that whenever we fit in another image, our model can really predict and tell us what we are doing, okay, the actual image that is. All right, so we are fitting in our X train, Y train model, and we say validation data, of which what the validation data means, our model need to validate the accuracy of this. All right, so it's going to use our test, our X test and our Y test data set to validate for this train, X train and Y train. So as the model is seeing these images, the model is also validating the images. All right, so that's why we're saying validation data should be X test and Y test, while the model needs to fit in or to see these images 10 times over and over again. All right, so let's just wait while it's running. All right, let's just wait. All right, so our model has been able to fit in, to run. All right, so 10 times. Now we started at the accuracy of 0.3694, and after 10 times of running, it get to 0.86%. okay, now the validation accuracy is at 0.70%. now the loss sign is at 1.06. all right, so this is how we are able to train our model. So let's go ahead and evaluate our model. You can say, okay, test underscore loss underscore test underscore accuracy equals to, we say model dot evaluate what evaluates our X underscore test and Y underscore test. Okay, so let's go ahead and run it. Okay, we have accuracy of 70%. We look at here at our validation accuracy is 70.50, so we have here as 70%. Let's go ahead, all right, and print the let's say print test AC accuracy. We are having it as 0.70%. so let's go ahead and do prediction. You say, okay, model dot predict, okay, predict what X underscore test. all right, so let's go ahead and run it. It's going to run for us and it's going to give us an array of prediction. We can go ahead and just look at just one of it. Okay, sorry, see the first, and we run this. Oh, sorry, this won't go. Okay, let's just leave it at that. Predict X test, run. Okay, so it gives us an array of this. So this is how we can build our model using convolutional neural network. So the first thing we need to do, was that, let me go ahead and put, okay, first we imported our dependencies. all right, the second one we need to do, we loaded our data set. These are the functions. And the next thing, we need to normalize our data set. Our image, this image is a rate of 30 by 32 by 32 pixels. okay, so it's from the series of 0 to 55, 0 to 255. so we had to normalize it to 0 and 1. That's why here in our training we are having it as this. all right, so now after we've been able to normalize our data set, we had to do what? To look at the shape of the X train and X test. The X train have 50,000 and the shape is 32 by 32 and it has 3 channels. right, so while the X test is 10,000 and it is 32 by 32 and it has 3 channels, that is the RGB. okay, red, blue and green or colors. That is the 3 channels in every image. All right, so we now went ahead and look at, we visualize our data set. We see figure size 10 5 by 5. Okay, we can also increase this to 10 by 10. All right, it's a choice. You can choose whichever one you want to use. Okay, and if I go and run this, it's going to run and give us a larger image, but it is not eye appealing. All right, so I'll leave it at that 5 by 5. So the figure size is talking about the size of that image. All right, so this is at least something good. All right, so now let's go ahead. If I remove this gray, okay, the C map looking at, all right, we want to look at the image color. Okay, the C map did not even, C map equals to gray. Let's see if it runs. Okay, right, so now we went ahead and did what, and to build our convolutional neural network. These are the functions. Okay, we imported sequential here. If we look at our, say, from TensorFlow carriers, import data set, layers, models, and this sequential is part of this TensorFlow. All right, you can also import it separately, sequential. All right, so we are using models of sequential, and it's an array, sorry, it's a list, layers or convolutional 2D 32 by 32. All right, and the input shape is this, and the max pooling this. So if you want me to explain each of these concepts, okay, what this conv 2D, max pooling, and flattened dense does, do well to put in the comment section, and I will do a separate video and to explain what they mean and how they are being used in this CNN. Okay, we also have model to compile. If you want to know the meaning of this optimizer, Adam, and all these laws and metrics, do well to put in the comment section. I will show you how I'll explain everything it is. So at the end of our screening, our training, our model was able to look and make a prediction, and we had the accuracy test about 0.70%. So it's not bad. It's a good model, so it can successfully predict. And in our next tutorial, I'm going to show us how to fit in a new data set or a new image, and our model will make prediction. So if you are seeing this video for the first time, my name is Okunamo George. I teach Python, data science, and machine learning generally. So, and also, if you are not subscribed, do well to hit that subscribe button. And if you are a returning subscriber, thank you, I love you. Please do well to share this video, put the comment on the comment section, and also like this button so that YouTube can also share this video or recommend this video to as many persons that wants to learn neural network. Thank you, and see you in our next tutorial.